Why is wet bulb temperature important for mechanical engineering? Imagine trying to cool down a hot room or keep industrial processes stable. You might not realize that a simple measurement called wet bulb temperature plays a big role in all of this. It's a key part of understanding how air behaves in systems like heating, ventilation, and air conditioning. Wet bulb temperature is the lowest temperature air can reach through evaporative cooling. It's measured with a thermometer wrapped in a wet cloth exposed to airflow. As water evaporates from the cloth, it cools the thermometer, giving us this important value. This temperature is always equal to or lower than the regular air temperature, which is called the dry bulb temperature. The difference between these two temperatures tells us a lot about humidity levels. Knowing the wet bulb temperature helps engineers figure out how much moisture is in the air. When the wet bulb and dry bulb temperatures match, it means the air is completely saturated with moisture. This is essential for designing systems that control humidity and prevent problems like mold or condensation. It also helps in calculating relative humidity, which shows how humid the air really is. In HVAC systems, the wet bulb temperature sets limits on how much cooling can be achieved through evaporative methods. For example, cooling towers use evaporation to lower water temperature, but they can only cool air down to the wet bulb temperature. Knowing this helps engineers design more efficient cooling systems that use less energy. Wet bulb temperature is also vital for assessing heat stress on people. It combines temperature and humidity into one number that indicates how hot it feels and whether conditions are safe. This is especially important in workplaces or outdoor environments where heat illness could happen. In psychrometrics, which is the study of moist air, the wet bulb temperature helps determine other important properties like enthalpy or total heat content. By plotting dry bulb and wet bulb temperatures on a psychrometric chart, engineers can see how air will behave during heating, cooling, or dehumidification. This guides decisions for ventilation and air quality control. In industrial settings, controlling moisture levels is critical to prevent corrosion or damage to materials. The wet bulb temperature helps monitor and manage these conditions effectively. In short, wet bulb temperature is a simple yet powerful tool for understanding air's moisture content and cooling potential. For mechanical engineers working on HVAC systems, psychrometrics, or industrial processes, it provides essential data to design better, more efficient, and safer environments.